In this tutorial, I'm going to use elemental row operations to find the inverse of the matrix, which has rows 0, 0, 0, 4, the second row 0, 0, 6, 0, the third row 0, 8, 1, 0, the fourth row 10, 0, 0, 0. So given that matrix there, to find its inverse using elemental row operations, we have to write the augmented matrix first. And the augmented matrix is the matrix which is obtained by appending the columns of two matrices. And in this case, to find the inverse, we append the identity matrix, which is of the same size as the given matrix. So the augmented matrix would have the matrix A, and appended there would have the identity matrix. To get the inverse, we would have to perform elemental row operations until we get the identity matrix on the left of the augmented matrix. So we would have elemental row operations until we have an identity matrix on the left, and what will be on the right will be the inverse of the original matrix A. So in this case, let us go on and append the identity matrix, which is a 4x4 matrix, which is ones on the main diagonal. So we would have our augmented matrix there. Yes, the matrix A, the given matrix that we have, and on the right, we are having the identity 4x4 matrix. But for us to get the identity matrix on the left there, we will need a 1 there, and we'll need a 1 there, and a 1 here, which we already have, and we need a 1 there where we have the 0. So we have to write another matrix. And for us to obtain the values that I said, we would need to use elementary row operations. So on those highlighted parts, some of them they are zeros. But let me first start by making them non-zero. And I'll start by interchanging some of those rows. So for example, we have the row 4 there. It has a non-zero digit there on the corresponding position where we need a 1 on the first row. So it will be better if we interchange row 1 and row 4. So the elemental row operation, we interchange row 1 and row 4. What was row 1 becomes row 4, and what was row 4 becomes row 1. So in our new augmented matrix, we would have our row 1 will be 10, 0, 0, 0, 0, 0, 0, 1. And this was the row 4 in the augmented matrix, which is above. We have now made it to be row 1. And what was row 1 there? We'll make it become the row 4. So our row 4 now will be 0, 0, 0, 4, 1, 0, 0, 0. I now go on and look at the second row there. It has a 0. But let us use the third row, because it has an 8 there in the corresponding position. Because on the highlighted part there for row number 2, we need a non-zero element there. So to get that non-zero element, I interchange with row 3. So we interchange row 2 and row 3. And our new row 2 now, we have a 0, 8, 1, 0, 0, 0, 1, 0. And our row 3 now is what we're having as row 2 above. So it will be a 0, 0, 6, 0, 0, 1, 0, 0. So that's our new augmented matrix there. But if we now look at the elements there, we have here, you have a 10, but we need a 1 there. And here we have an 8, but we need a 1. Here we have a 6, but we need a 1. Here we have a 4, but we need a 1. So what you have to do is we write another augmented matrix and then look at the elements that we have. For the first row, we are having a 10. But on that position, we said for us to have an identity matrix, we would need a 1 there. But when you have a 10 and you need a 1, you have to divide by 10. But in this case, when you are looking at matrices, you cannot just divide just one element. You would have to use elemental row operations. That is, you multiply that whole row by 1 over 10. So in this case, to have a 1 there, we would transform row 1 to 1 over 10 row 1. And when you do that, it will be 10 divided by 10 is a 1. 0 divided by 10 is a 0. 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 1 divided by 10 is 1 over 10. We are dividing all the elements in the row by 10. So that's our new row 1. And looking at row 2, we have an 8. And when we have 8, if we need a 1, we divide by 8. So what you have to do is we transform row 2 to 1 over 8 row 2. So for the first one, it will be 0 divided by 8. It gives us a 0. 8 divided by 8 gives us a 1. 1 divided by 8, it gives us 1 over 8. 0 divided by 8, it gives us a 0. 0 divided by 8, it gives us a 0. 0 divided by 8, it gives us a 0. 1 divided by 8, it gives us 1 over 8. 0 divided by 8, it gives us a 0. We now go on to row number 3. On row number 3, on the highlighted part there, we need a 1, but we are having a 6. To have a 1, when you have a 6, we divide by 6. So what you have to do is we have to transform row 3 to 1 over 6 row 3. And when you do that, we get 0 divided by 6 is a 0. 0 divided by 6 is a 0. 6 divided by 6 is a 1. 0 divided by 6 is a 0. Then you go on, 0 divided by 6 is a 0. 1 divided by 6 is a 1 over 6. 0 divided by 6 is a 0. 0 divided by 6 is a 0. We now move on to row number 4. On the highlighted part there, we need a 1. And to get a 1, when you have a 4, we divide by 4. So what you have to do is transform row 4 to 1 over 4 row 4. And when we do that, row 4, transforming it to 1 over 4 row 4, we get 0 divided by 4, it's a 0. 0 divided by 4, it's a 0. 0 divided by 4 is a 0. 4 divided by 4 is a 1. 1 divided by 4, it's a 1 over 4. 0 divided by 4, it's a 0. 0 divided by 4, it's a 0. 0 divided by 4 is a 0. Now let us inspect the matrix that we have on the left. Is it the identity matrix? In this case, we see that it's not an identity matrix. The identity matrix is ones on the diagonal, and all the other elements that are not on the main diagonal are 0. But in this case, we have this element there. It's not on the diagonal. It's a 1 over 8. So it's not yet an identity matrix. And for us there to have an identity matrix, we need to make that a 0. And to do that, we would use elemental row operations, and we'll be making use of the 1 which is in row 3 there. So what we do is we multiply row 3 by 1 over 8, then subtract that from row number 2. Because what we are having is a 1 over 8. If we need a 0, we need to subtract 1 over 8. So we are making use of that 1. So what we do is we transform row 2 to row 2 minus 1 over 8 row 3. And when we do that, what we should get there, we write all the other elements as they are, because they are not changing. So for the first one, it will be 0 minus 0. It gives us a 0. Then for the next part there, we are saying it's row 2 minus 1 over 8 row 3. It will just be 1 minus 0. It gives us a 1 there. Then you go now to the 1 over 8. It will be 1 over 8 minus 1 over 8 times row 3. Then it gives us a 0. Then for the next one is 0 minus a 0 is a 0. For the next one is a 0. And for the next part now, we are having a 0 minus 1 over 8 times 1 over 6. So it will give us minus 1 over 48. And then for the next one, it will be just minus is 1 over 8 minus a 0 is 1 over 8. Then for the next one, 0 minus 0, it gives us a 0. Now if you look at the matrix which is on the left there, this one that I've highlighted is now an identity matrix. It has ones on the diagonal. And when we started this, we say that when we perform the elemental row operations and we have the identity matrix on the left of the augmented matrix, the matrix which will be on the right will be the inverse of the matrix that we were looking at. So in this case, what is on the right there will be the inverse of the original matrix. So in this case, we'll be having the inverse of the original matrix is the matrix which has rows. The first row, 0, 0, 0, 1 over 10. Second row, 0, minus 1 over 48, 1 over 8, 0. Third row, 0, 1 over 6, 0, 0. Fourth row, 1 over 4, 0, 0, 0. So that's the inverse of that given matrix that we had.